Hello everyone, my name is Anita and today I'm going to talk through one of my first data science projects. I will share my insights and findings obtained from the analysis of a very famous Kaggle competition dataset, which is the wine quality prediction. So let us get started. Here is a brief overview of what we are talking today. First, I will explain the objective of the study and the goals we are trying to achieve through the analysis. Then I'll give you a glimpse of the dataset and also explain the method used for the analysis along with the machine learning model used. And then we'll shift into the insights derived from the analysis and end up with conclusions. Let me talk a little bit about the objective. The objective is to arrive at a machine learning algorithm which will predict whether the wine is good quality or bad quality based on physicochemical properties. The physicochemical properties of wine refer to the chemical and physical characteristics of the wine. This includes factors like acidity levels, sugar content, alcohol concentration, etc. So let us now look at the dataset. Let us get familiar with the dataset. So the data is provided by the UCI machine learning repository and is available online. We have about 1600 observations or samples. And as you can see here, we have about 12 variables that has been provided. Variable 1 to 11 are the input variables, which are the physicochemical properties of the wine, and the 12th variable is actually the target variable, which is the quality, and the score is given between 0 to 10. 0 would mean the worst quality wine and 10 would mean the best quality wine. While I was exploring the dataset, I was curious to understand where are these samples coming from, and I found that these samples are coming from the Portuguese Vinho Verde wine. This is a beautiful view of the Portuguese Vinho Verde wine garden from where our samples have been collected. Now let us look at the methodology. To solve the problem, I primarily used Python Colab to import and transform the data and then analyzed and iterated based on findings. So before we look at the model, let us look at some of the exploratory data analysis findings which I think is interesting and worth sharing. This will also help to get a glimpse of what goes behind the scenes to arrive at the model. Alright, let us examine one of the variables, which is alcohol. Intuitively, I feel a higher content of alcohol might translate into higher quality of wine. Let us see what the data is telling us. On the left hand side, we see that the alcohol is having a moderate positive correlation with quality of 0.48. Correlation is a statistical measure which tells us the strength and direction two variables move in coordination with one another. For example, say x and y are two variables. An increase in x also increases y, then it is a positive correlation. If an increase in x causes a decrease in y, then both are negatively correlated. The closer this value is to 1, shows the strength of the relationship. On the right hand side, we have box plot. So rather than seeing one aggregate metric like the mean, we see a couple of different metrics in one graph using the box plot visualization. The lower part of the box is 25% and the upper part is 75%. And the line which is in the middle is the 50th percentile or the median value. So when we look at these median values for different levels of quality, we observe that the median value of the alcohol increases with the increase in quality of wine. This again confirms positive relation between these two variables. Let us quickly look at two more variables. Residual sugar. This is interesting. Residual sugar has very low correlation with quality of minus 0.01. This is very insignificant number to consider. Looking at it visually too in the box plot, the median value or the middle line in the box of residual sugar remains relatively same across increasing levels of wine. Now let us look at variable volatile acidity. Volatile acidity is a measure of the wine's volatile acids or gaseous presence. And this variable has a moderate negative relation of minus 0.39 with quality of wine. So this means higher volatile acidity, lower the quality of wine. And we see this in the box plot. The median value of the volatile acidity is decreasing as the quality of wine increases. Here we are looking at a correlation heat map which gives correlation of all the 12 variables with one another. This helps us in analyzing which variables to drop and which ones to keep for our machine learning model. Deciding quality input variables is fundamental for the machine learning model to perform well and provide accurate results. After the exploratory analysis, now let us look at the feature engineering steps which have been performed on the data to prepare for the modeling. Some of the variables which showed very low correlation with the quality were dropped. Also some variables which showed very high correlation with one another were dropped to avoid the problem of multicollinearity. For the purposes of classification, quality of this wine, which was given on a scale of 0 to 10, was clubbed as good and bad. Less than 7 is classified as bad quality wine, and 8 and above are classified as good quality wine. All the variables were in different units, so we standardized the data before feeding it to the machine learning model. How to decide which model to use? This depends on the nature of the problem. This is a classification problem. Based on input variables, wine needs to be classified as good or bad. It is observed that the sample has 13% values for good quality. So it is an unbalanced dataset. This needs to be factored in while selecting the appropriate machine learning model. While looking at the box plots, we also saw that the data has some outliers as well. Considering these points, 4 models were tested for accuracy, and these are the results. Looking at the various metrics for accuracy, we find that the XGBoost gives us a 90% accuracy. Also, the recall and precision scores are better in this model. The ROC curve 2 in XGBoost model gives a good AUC, area under the curve, score of 0.92. Also with cross-validation, the average accuracy is close to 90%. Hence, XGBoost model scores over other models for predicting wine quality based on the input variables. In conclusion, this analysis provides a useful model for assessing the various chemical components in wine that give wine its quality. By analyzing the chemical and physical properties of wine, we can now uncover the secret if wine is a great wine or not. I hope you find the analysis interesting. Thanks for listening.